Now in this part we are going to see how to find out the absolute extrema and the critical numbers of a rational functions. So for that purpose you have a rational function here, f of x equals to 6x square divided by x minus 2. So you all know whenever there is a x value in the numerator as well as in the denominator, the function is said to be rational function. As I said before, for any function, the first thing is write the domain beside and find out that whether you have any discontinuity or not. So let's see here. For the rational functions, you all know that we take the denominators and make it equal to 0. So bring the 2 on the next side. So you will get x not equal to 2. It means at 2 you have a discontinuous graph. So what you are going to do, second thing, is to take the derivative. So here it is a quotient of two functions. So you will apply the quotient rule. And it is very obvious that the quotient rule says gf prime minus fg prime. So f and g prime divided by g square. And also you have been known that f is the numerator, is the function in the numerator, whereas g is the function in the denominator. So wherever f is written, you replace by 6x square and replace g by x minus 2. So see, here g is written, so your g is x minus 2, so write it down. Beside f prime is written and f is 6x square, so you will write here 6x square with prime. Prime means take the derivative. Then the function has a minus sign, so write here the minus sign. Then f, it means 6x square, and g, that means x minus 2 with prime. And divided by g square, it means x minus 2 whole square. Now don't open with any algebraic operation the denominator. Keep the denominator as it is throughout the questions. Now here in the numerator, let's see what is happening. X minus 2 as it is, but on 6x square you have a prime, so you will take the derivative. So 2 times 6 will gives you 12x. This 6x square will be written as it is, and now the derivative of x is 1. So you wrote here. Now what you have to do, you have to solve it, means open the brackets. So here you will use the distributive property to open the brackets. So 12x times x will gives you 12x square, and 12x times 2 will gives you 24x. This minus as it is, and x square times 1 gives you 6x square. Now look at the alike terms. So 12x square and 6x square. My 12x square minus 6x square, you will get 6x square, and negative 24x you will write as it is. Now set the equation equals to 0 in order to find the critical numbers. So at this stage, because you have numerator and denominator, so simple thing is that you cross multiply. Now this denominator x minus 2 whole square, when it will be multiplied by 0, so you will get 0. So that is here 0. And 6x square minus 24x multiply by 1 will gives you the same terms. Now at this stage, you can see there is a common here. So take the common factor. So 6x square minus 12x. So 6x is common in them. So you write the 6x as a common factor. Now 6x square here and 6x is written outside, so you have been left as x, this minus as it is, and now 6 times 4 will gives you 24. This x is already outside, so you will not write. Close the bracket and write it equal to 0. Now one time you have to write the first factor, that means 6x equal to 0, and the second time you will write the second factor, that means x minus 4 equal to 0, and solve for x. So divide here 6x equal to 0, divide both sides by the 6 and you will find out x equals to 0. Now in the second factor, bring the negative 4 on other side. So you will get here x equals to 4. So this is your critical number. Now again, why these are the critical numbers? Because they are not the discontinuities. So here, just to make you feel comfortable, I wrote the question again. Here are the two critical numbers which we just found in the previous slide. And here is the closed interval. So to find the absolute extrema, one by one, you will substitute your critical numbers and the terms of the closed interval in the question. So replace one by one all the x given in the question with these four numbers to find out the absolute maximum or absolute minimum. So here everything is calculated. On replacing the 0 in the question, you got 0. On replacing negative 2 in the question, you got negative 6. And similarly, on replacing 1 in the question, you got negative 6. And the 4 in the end, when you replace it, you got 40. So on comparing these four numbers with each other, you can see that at f of 4, means at x equal to 4, the y value is 40. So this is the highest value of among all these numbers. Now have a look. Here you have 0, negative 6 and negative 6. So there are two same values, but they are the least values. So they both will be considered as absolute minimum. So one important thing, that in a graph, the lowest point can be 2, can be 3, even can be 4. They all will be considered as absolute minimum or absolute maximum, depending on the highest or the least point.